Okay, here's a quick walkthrough of setting up a very simple simulation. Um, so this is my sample modeling code. It has two classes, a person class, which takes a person, assumes they're not infected, adds them to a population, can kill them at some point, and can pass it on at some point. And then it has a data writer where we output our our data about our population. Right now it just outputs the length of the living and the length of the dead. And then it's got some functions, one that creates people and one that runs the simulation. Okay, so the first thing to think about improving in this model is what happens each round of the game, and that's what we call the tick. I think of that as a clock, so I like to call it a tick method. Each round of the game, what happens? And my sample code grabs you a list of 5 friends, and then it says do something with your friends here. So an obvious thing to do would be to look at each friend. We'll just use a for friend and friends loop. And then we could write some logic here that if our friend is infected, we are infected. That is a simple infection model. This has no incubation period, no delay, which means that within each round the infection is going to spread. It's not a bad idea to add a little bit of a delay. So then we could add a contagious variable. And then we could say if friend is contagious, then we become infected. And now if we're infected, we become contagious. So now we could add some logic that says if self-infected, actually let's add that to the top here. So now at the beginning of the round, we say if we were infected last round, let's become contagious this round. So now each round of the game, if we're infected, we're contagious. We grab 5 friends at random, and if our friend is contagious, we become infected. That seems pretty good. If we want to kill ourselves, we could also say if self-infected, let's imagine we roll some dice. Random, 1, 6. So let's say we have a 1 in 6 chance of dying when we have a disease. And let's give us, well here, let's say we roll the dice. So roll equals random. If roll equals 1, we die. And let's give us a 1 in 6 chance of becoming no longer infected. Beautiful. You can imagine we might add an immunity as well. We won't do that for now. We'll just say that our behavior changes when we're infected. So there we go. Now we have some chance of dying, and we have some chance of becoming infectious. All right. We look at our simulation now. Run simulation is going to create a data writer, create people, run however many ticks we say to run, and output the data. One last thing we need to do is infect patient 0. Patient 0 infected equals true. Let's run the game. Okay, when we run the code, nothing happens, and that's because rather than printing to the screen, we've outputted to a file. So now we will have to open the file, data, and take a look at it. It shows the living and the dead each round. And we can see we quickly start killing people off. Oh man, our infection eventually appears to kill everyone. That's a pity. I thought some people might survive. So if we want to look into some more detail, we can go and look at our data writer and add some more lists. So output data right now adds the length of the population and the length of the graveyard. Let's count up the contagious and the infected. And we'll just go through the people. So for P in person population, if P infected, infected plus equals 1, if P contagious, contagious plus equals 1. And now I can add to this infected, contagious, add it to my header as well. Beautiful, run this code one more time. Reopen this data. And now we have live, dead, infected, and contagious. And I can see in the beginning I have one person infected, 5 people catch that infection after 1 round. Ooh, it looks like something's wrong with my infection code because notice that before anyone was contagious, 9 people got infected. Ooh, that doesn't seem right. Let's see what I did wrong. If friend not contagious, infected equals true. Oh, I guess they got contagious during the second round. That makes sense. So round 1, oh, nothing happens. Round 2, round 3, and so on and so forth. Okay, let's try some simple things. Let's make you only have 2 friends around instead of 5. We'll notice this one. We can make a copy of this. Data 5 friends. There we go. I can run this code one more time. It's going to run. Now let me open up the new data. And we'll see indeed it's spread significantly slower in this version. Now everybody dies eventually, which is a little surprising. You have a 1 in 6 chance of dying each round that you're infected. So there's 10 people infected, we have 1 dead. Next round, 13, 4 dead. It seems to be more than 1 in 6 are dying, but that may just be bad luck. Or maybe I made a mistake. If we want to, we could add now immunity. So at this point, if you are infected, you become contagious, and you also become immune. So now we'll say if self-immune, return. No need to worry about interaction. Else for friend and friend. So now we're only going to interact if we're not immune. We could count up the immune as well. Repeat up. Immune equals 0. Okay, time to run the code one more time. Take a look at data, reload. Now we are starting to collect everyone who's infected is also immune. So if you're infected, here we go, immune. So we're now collecting more immune people, which is good. And at this point, my infection, rather than killing off everybody, hits a stable state where it kills off half the population and half has survived. And that makes sense because my odds of getting cured were the same as my odds of death. If I go back and change my odds of dying, let's say that you have a 50-50 chance of getting better each round. We should see fewer dead. Let's run it. Take a look at the data. Oops. Oh, you know what happened is my first person survived. Yeah, so that round nobody died. The second round, we have some death. But we'll notice with 50% recovery rate, you have a much better survival. And here I'll run it one more time. This time only 5 died. Run it again. This time nobody dies, or one person got better. So you can see how complexity starts to get a little more fun. Here we just killed off one person and then the other person got better. You can now start to play with some real numbers and real diseases and see how this changes things. I will stop recording.